Okay, let's get started. So like I said, today I want to keep going over what we were talking about with discrete probability distributions. Hey, folks, I hate to ask, but what is it that you're doing on your phones that's so important that I can't wait until after my lecture?
Olivia got a new puppy and she's showing me photos of it.
Well, I'm sure the puppy is adorable. It's not really part of our subject content today. So I'll tell you what, I'll let you keep looking at the puppy if you can tell me how it is that your cell phones are letting you communicate with each other right now. In order for Navi to text Olivia, basically the wavelength from her cell phone has to go to a local tower. The tower processes that signal and then routes it back to Olivia. This is a really great example of how satellites work when they're on orbit. They take a signal from Earth, it travels up to the satellite, we call that the uplink, and then that signal's bounced back down to Earth to the receiver. We call that the downlink. Imagine you're driving to your first job interview. You have to make a great first impression. You can't be late. You have your GPS up on your dashboard. It's telling you where and when to turn. Suddenly, without warning, the directions stop. The screen goes blank. What happened? Where were those directions coming from to begin with? And why did they stop now at the worst possible time? So it turns out there's currently about 8,000 satellites in orbit around Earth. There's several types of satellites, and you're probably familiar with a lot of them. So for example, there's weather satellites, there's navigation satellites, for example, the thing that allows you to use GPS on your phone. And then of course, there's communication satellites. We put all these satellites into orbit around Earth to carry out all sorts of jobs, whether that's monitoring the weather or broadcasting television or keeping us connected to each other via cell phone. Now, if at some point anything goes wrong with the satellite, it's programmed to alert the operators back down on Earth by sending an error code or an error signal. Once that happens, the operators have to diagnose what went wrong with the satellite to try and get it back up and running as quickly as possible. Now, this is a complicated process, so for a little bit more help on how it all works, let's phone our friend Christine at the Aerospace Corporation to get some more insight.
Data sets from satellites are vast and daunting to analyze. Some can collect data every millisecond. There are also hundreds of active satellites in orbit and data from thousands of past inactive satellites. This can be too much data for one human mind to analyze and understand alone. This is the best part about having tools like artificial intelligence and machine learning. AI and machine learning models can sift through all of the data and flag where the data is similar to alerts that we've seen on past crafts or projects. I can then go back and look through at just that part of the data and determine if the data is actually an anomaly worth investigating or if the computer just got it wrong. It's like having a coworker in the office that can help me understand the error codes from these satellites. The machines are not always perfect, but they greatly reduce my workload.
Thanks, Christine. As you can see, satellites are ubiquitous, and they help us complete all sorts of day-to-day tasks, whether that's making sure that we get to our first job interview on time, or being able to watch our favorite show on TV, or being able to text our friend. But it's important to note that satellites are more than just the machine. There's an entire fleet of people that are responsible for operating them, and they are engineers with all sorts of different academic backgrounds coming from different disciplines. When something goes wrong and the satellite sends an error code down to Earth, we need to bring all these people to work the problem together so we can make sure that satellite's up and running as quickly as possible. Now, of course, with the artificial intelligence becoming popular, there's plenty of opportunities to integrate that into satellite systems. Can you imagine yourselves using AI to work in aerospace?